Okay, lab 24. Yeah, might as well. I said, why don't we just do the HTML parser, since y'all probably all have a good experience with that already, right? Good. This lab will explore tokenizing HTML tags with Flex. Implement the following classes. Basically, the HTML tag represents an HTML tag, whoa, i.e. optional slash name, optional name equals value attributes, optional slash at the end with the ending bracket. Okay? When a tag has a slash, it is labeled an end tag, but the name does not contain the slash. So if you end with \a, don't put the backslash in the name. You just flag it as an end tag.
Oh, we mean forward slash.
Forward slash, thank you. Forward slash, thank you. All right, I made an HTML tag. By the way, I've written a lot of this, some of this for you. Yeah. Oh, nice. Has a name, as an end tag. There is one thing missing, namely the attributes. I guess we'll have to fill that out. You can create a tag giving a name, add an attribute, get the attribute's name, clear it, and then I have some getters and setters for its name as well as end tag. Is it an end tag? Then the actual parser is a vector of those tags. That's all. I'm just going to leave it that way for now. Advanced parsers will store it differently, but I'm just going to try and make it simple, so we'll just make it a vector of tags. All right? Because normally the way they're nested in the HTML page is very important, but we're not going to mess with that right now. We're going to keep it simple. Your parser, you can default constructor, or pass it a file name, or I can pass parse and have you parse it that way. Once it is parsed, you're going to fully parse it, aka call yylex, which will tokenize it, send the tokens to your program. You'll have to set that up. And then you should get everything parsed. Then you can get the number of tags. You should be able to return me a tag. And then the other functions, I'll show you how those work in a moment. All right, let me go over and jump over to the code, because I think a lot of this is going to make far more sense when you look at the template that we've already written. Let's go and get rid of that. Lab 24. All right, so I have pages. What do I have? Hey, look, index.html. That probably looks familiar. So we'll go and look at source html.l. So I've gotten this started. So notice, I've included HTML parser.hpp, that's our code. Extern HTML parser :c. This is how we will interact with the current parser when Lex is being called. This is basically the hook back to our object that we've created. On a less than sign, we hook back to our, oops, wow, that was bad. On a less than sign, we call our HTML parser start tag function. On a greater than sign, we call the end tag function.
That is extremely hard to read on the board.
Up there?
Yeah, putty.
Yeah, just look at putty. Yeah, SSH. What is this line doing?
It just skips white space.
Yeah, we ignore white space. So you can add all the white space you want, it'll just ignore it. Isn't that nice?
It's kind of racist.
Ah, I liked it. That was good.
Wow, by the way, I'm impressed.
Now bringing it back around. Nice, nice. All right, what does this one do? Does it have a dot?
Just prints out the carrots on the
Right. So what? Notice this is actually very good to put at the end of your Lex code. If it's not able to parse something or tokenize it, it goes ahead and matches this last one. Just says, I have this character. I have no idea what to do with it. You need to figure out what to do with it. Or actually, maybe you don't need to, depending on how you write your parser. But do you see how in this one, I've already given you at least 2 tokens, and it's going to call your HTML code, namely parser.cpp start tag right here. It would call that function. And then I have C parser set up here. So let's go ahead and at least set up a couple of things here to get this going, because, oh wow, we're running low on time. Oh well. I'm assuming you want to at least do some of this lab in class.
Yes.
Yeah.
Okay, good. I've never had a problem with that. I always want to do part of it in class. It's nice. All right. Our HTML tag. Let's see what we got. Im tag. So we have im tags, static. I mean, a vector of HTML tags. That's great. So we need to set up the parser. Did I at least give you that? Oh, please tell me I did. Good. So we can go ahead and parse it. Oh, I did this for you. Beautiful. I set YYN to the file to open. Notice I set the CHTML parser equal to this. That is this variable right up here. Since I'm externing it right here, it will link it into the Lex file. And then I call YYLex to actually start the tokenizing, which will then call our functions. Okay. So, let me show you that at least it's working. Or hopefully it is. Start tag found. If I do make. I think it's actually make a simple test. Oh, right. We actually got something going. So it is finding a start tag. That's good. Now let's see what the simple test actually looks like. Tab new, test, simple test. Creates an HTML page with that page, and then just make sure the number of tags is 6. That's all it's doing. So let's go ahead and work through this one. Do y'all see what this test is? Sorry. Okay, good.
Is there an upgrade for this line?
Yes.
Okay.
I don't know if it works yet. I tested against my code, but I haven't tested in the system yet, so I'm gonna have to work that one out real quick. All right, starting tag found. All right, so we find a start tag. What should we do? Okay.
So what is the C back there at the end of that?
Ooh, wow. I didn't delete all the code. Do I have C tag? So static C tag, that's our current tag. So actually it's ctag.clear is what we want to do, because that's going to be the current tag we're in there, and then we want to push it back when we're done.
But wouldn't that, like if we have a tag nested inside a tag, so it goes to this tag, makes the C tag that, then goes to this tag, changes the C tag to that, then
You're thinking pointers. When you do a pushback, it's going to copy it.
but
There were no nested tag. Like there are no
Yeah,
We're not
so-
doing tag nesting.
okay.
Yeah, yeah.
But when it ends a tag that, when it ends the tag, wouldn't it just like push back the same tag multiple times?
Well, we call ctag.clear.
Yeah.
.clear, and the idea there is that it's going to go ahead and, oh, we didn't clear anything. Well, we should probably clear some things. So what do we have? We have name and m. So when we call clear,
name equal blank string.
yeah, and then end tag, whoops, which is a boolean, should be false. All right. Okay. So if we're calling start tag, clearing the C tag, and then pushing it at the end, how do we know how many number of tags we have?
The size of m tags.
Yeah.
So it doesn't matter what is in the vector, only the size matters.
For a simple test, yes.
But isn't it just gonna push the, like for all of the, let's say there are 3 starting tags and 3 ending tags. Wouldn't it just for all 3 ending tags, wouldn't it just push the last starting tag?
No, there's no stack or anything in this one.
But how would it work? How would this, so it says m tags will push back C tag. If C tag wasn't changed since the since the last
And
start.
it's going to create another copy of the exact same thing and put it on the vector.
So, and it doesn't matter the vector isn't correct here.
It's not correct for this one. Obviously, we're going to need to do other things with attributes and names, which you are going to have to implement with your Lex specification, calling some function that you'll have to create inside the HTML parser.
Which you were nice enough to give us in the slide.
Yeah. Right. Yes. Yep. Just try and help you out here. So hold on. Where are we? Return. There we go. All right. Let's see if that actually works. Wasn't able to tokenize all that, but it passed.
Yeah. Wait. Okay.
Right.
Yeah, yeah.
It passed. It
just
couldn't.
doesn't
It
work.
didn't know what to do with HTML bod body b/b/body/html. It didn't know what to do with all that, but it was able to at least figure out the how many tags there were, which is a great start. Going back to the HPP, notice that I am going to be testing other things. I need to be able to get each tag.
Let's go into the stack.
Implement. I bet you'd love that, wouldn't you?
I mean, it's not that bad. Just determine the vector, the square bracket, or whatever index it is.
So get tag is where it's going to get a little more complicated, because remember, get tag needs to get the tag, but each tag, you need to make sure the name is correct, the is in tag is correct, and you also need to be able that the attributes are actually set correctly as well. Notice I am not storing that in HTML tag. And our last, I guess the last bit to at least help you out, how would we store the attributes?
Maybe a hash table, like with the ID.
You could do it. Oh yeah, you could do that. You could definitely use a hash table.
So href as the key and the link is the value.
Yeah, we could do that. Yeah, I like that. All right. Anyone remember the C++ specification on that? Oh, it's going to ask me for a password. It was map. Yeah, I remember that. Let's see. Okay, yeah, maybe that's all you got to do. We'll try that. So, map of.
Going to include it.
Yeah.
Yeah.
All right, let's see if that works. Did it compile? Looks like it's going to compile. All right. And then once you are able to parse those attributes, you can go ahead and put them in.
And then just make sure you don't use the square brackets to find anything. And this will occur.
Right. All right. Sweet.
So does that mean that we're gonna have to create a stack or something ourselves to keep track of the index?
Now all I'm testing is being able to get the tag in the order that it appeared.
Okay,
I don't
so-
care about balancing. There is
so-
no balancing in this one.
Basically, so when you find the starting tag,
But this, your code should parse incorrect HTML.
but wait, but why do we add it to the vector when it ends then? Why don't we add it to the vector when it starts?
The HTML, the vector list, I'm doing it this way to simplify the problem. This is not a full HTML parser. I'm simplifying the problem greatly. The vector is holding all the tags as they come in. And it's not holding start tag, contents, end tag. It's not doing it that way. It's considering a tag to be just between the two less than, greater than signs, okay? I know that's slightly different than the HTML specification, but I'm just doing it this way to make it easy. Yes?
The attributes, seeing as they're in one order when they come in, map sorts them alphabetically as they're stored.
It doesn't matter.
So
It doesn't
has
matter.
to be there.
No, because get attribute, I pass. Oh, it does give an index.
So I guess we'll have to use
Yeah. Good call.
something else.
All right, there we are. Vectors of pairs.
So I think I get it now. So we store both the starting tags and the ending tags as separate tags in the graph?
Yes.
Yes.
Okay.
Yes. And you ignore all the contents, unless they're a tag.
So like, as long as you store the attributes and the name,
Okay, yeah.
where they're sending.
Now I know what your question is. Here's the specification that I'm giving you. A full tag is a tag, contents, and another tag. So it can either just be one tag or a tag with some contents followed by another tag. A tag is the beginning tag, aka less than. Notice beginning tag's right there. Attributes can either be string equals string, string equals string attributes, or nothing. In slash, right there, in slash or nothing. And then end of tag, which is the greater than sign. And the string is possible into string and printable characters other than less than and greater than. Note, make sure you include quotes. Make sure the quotes are included, in other words. Don't give me what's inside of it, give it to me with the quotes. Otherwise, you will fail the autograder. Yes, I know this is not the exact HTML specification. This is what I'm giving you to keep life simple. Because the full one is far longer. Alright, HTML, Lex files been created to start your parsing. Please inspect that and add to as needed. This lab is actually, since you can use so much of the STL and you're using Lex, it is not very long code-wise. It's more of just getting it right. Okay. And if you can, somehow tell me if this makes, you think it'd make project 2 easier or not.
Well, if you could maybe in future classes like all of this before
Right.
programmers do and say that anyone who wants to can use it, but
Right. All right. Any other questions? How y'all doing back there? Tired? Okay. All right, guys. Oh yeah, this is due a week from today, right?
so
Good.
is this when all of our labs are due, like
Mhm.
late labs?
All right. Any other questions? Okay, that's it, by the way. There are no more labs, no more projects. You just have to do your final. I'll be in my office on Thursday if you have questions, or if you need me to come over here in the lab and help you out. I'll be there. Tuesday, do we have technically class on Tuesday? I think so. Yeah, so I'll do the same thing on Tuesday, but we've gone through all the material. Unless someone really wants me to do more.
So does that mean there will be no class on Thursday and Tuesday?
Correct. Yeah, we did everything.
Alright.
I do have a tendency to front load my classes, so this is how it ends up. You okay?
Does the school can drop by about review questions?
Right, I'm going to be in my office during class time, so just think of it as extended office hours. If you need me to come over here to your lab to help you out, that's perfectly fine. I'm willing to do that. Just make sure you grab me because it's easier for me to be in my office, right? And yeah, if no one's in here, I'm not going to be sitting over here on my computer trying to do work. I'm going to be in my office. So yeah, feel free to grab me during class time. That's extended office hours. If there's other people talking to me and you come in, I'll of course give you priority because it's class time. But yeah, any questions? Nothing? Usually this part, I have everyone going like, oh, it's over. But you always seem to be like,
That's
wait,
what I
what?
feel like right now.
Wait, what?
I'm like,
Yeah, you still have Project 4. That's right. Good old Project.
Thinking about that.
Vanilla Project 4. Yeah, so, yeah, I enjoy this class a lot. I hope you have, well, I guess y'all have a different opinion, but that's okay.
Yeah.
Fantastic. What's that? Woo. Well, if you really want me to, Richard, I will. But yeah, I would avoid that. All right, guys. Well, that's it. We'll hopefully see you next, I guess, in architecture. By the way, if you can, please take competitive programming, especially after this course. I think it's a lot of fun, and it will continue to improve your skills. And we get to compete against other schools. If it conflicts with the time, come talk to me. I've been always trying to figure out the best time to run it, but it's always going to conflict with someone, so that's the way it is.